Hello class, this is a video recording of our post-lab discussion of your Module 5 in our Analytical Chemistry Laboratory. So basically, i-discuss lang talaga natin dito yung mga answers nyo on your worksheet as well as your QFRs or your questions for research. So presenting you here today, I am Ma'am Christina Matibag and my partner with me is Ma'am Lena Yvonne Huco. So before we head on to our main discussion, let us just have a quick recall of the chemical solutions or the reagents that we made use in our laboratory demonstration. So here is your dish detergent, your 0.10 molar of your hydrochloric acid, your 0.1 molars of your sodium hydroxide, and then your acetic acid. So, mag-head-on na tayo sa ating data and results na mga na-observe natin sa ating laboratory demonstration earlier. So, quick review lang of our acid-base strength having your ionization. When we say ionization, it is where your positive and your negative are produced in a dissolved solution. Again, pag sinabi po nating ionization, it is where your positive and negative are produced in a dissolved solution. Okay, bida po dyan si strong acid and then si strong base. Kasi po, pag meron tayong strong acid and then your strong base, they completely dissociate in water. Okay, dissociate, naghihiwalay. Pag na-addan daw sila ng water, completely dissociate sila or naghihiwalay yung kanilang chemical compound. Okay, hence the chemical equation like here. Okay, yung hydrochloric acid mo, which is a strong acid, nung nag-add ng water, nag-dissociate siya completely. So, nahati siya sa hydrogen and then your chloride. For your strong base naman, having your sodium hydroxide, nung nag-add ng water sa kanya, nag-dissociate siya completely, kaya naging NH at OH na lang. Okay, kabaligtaran naman po si weak acid and then si weak base. Kapag kasi weak acid and weak base, they partially dissociate only. Katulad po ng ating chemical equation in your front, your CH3COOH, nung nag-add ng water sa kabilang side ng chemical equation, hydrogen lang yung nahiwalay. Nag-partial lang yung na-dissociate. Katulad din po yan sa iyong weak base. Okay, so ito, quick recap lang or review of the acid-base strength having your ionization. Kasi magagamit natin yan later on sa ating discussion. Next naman is your acid-base strength. Ang pinakapalatandaan natin dito sa ating acid-base strength is your 7. pH 7 kasi siya po si neutral. Anything beyond or yung mga preceding numbers na ma-observe mo na pH, acidic po sila. Okay? And then naman yung mga numbers, yung mga pH na mas mataas kaysa kay 7 mo, mga basic or alkaline sila. However, hindi lang sila nakaklasify as acidic and as basic. Meron silang classification according to their strength. Okay? For the pH of 0 to 2, we have your strong acid. The pH of 3 to 4 has a moderate acidic. Your pH na 5 to 6 is considered weak acid. So, ito yung ating baseline or palatandaan, si neutral na 7. Next naman is the pH of 8 to 9 is considered weak base. The pH of 10 to 11 is classified under your moderate base. And lastly, anything na observed that has a pH of 12 to 14 is considered a strong base. So ito po dapat nating tandaan at kabisaduhin. So next, here are the actual results of the pH according to the laboratory demonstration that was shown earlier. So sample number 1 is your 0.1 molar hydrochloric acid. Based on our observation, it has a pH of 1.67. So it is classified under your strong acid. Next naman po is your 0.1 molar sodium hydroxide. It has a pH of 12.56 according to the laboratory demonstration using your pH meter. It is classified under your strong base. Next naman is your 0.1 molar of your CH3COOH or your acetic acid. It has a pH of 3.32 and is classified under moderate acid or your weak acid. And then lastly, our dish detergent. It has a pH of 8.31 and is classified under weak base or moderate base. So, ang sabi po natin, yung mga soap natin, usually mga basic yan. Okay? Next naman is, if you're going to determine the pH of these following solutions or reagents that can be found in your laboratory or in our home, ito po yung mga ma-observe nating pH most likely. Okay? Your 0.1 molar NaCl, ito mga examples na lang to ha. It has a pH of 7 or it is neutral. Next naman is your 0.1 molar of your NH3. It has a pH of 10 and is classified under your moderate base. Next naman is your 0.1 molar NaHCO3. It has a pH of 9 and is classified under your weak base. Next naman is your light-colored soft drink. So, hindi naman na-mention yung brand dito. It has a pH of 4 and is considered a moderate acid. So, yung mga mahilig mag-soft drinks dyan. Okay? Lastly is your light-colored fruit juice. It has a pH of 3 and is considered as moderate acidic. So, next, discuss na natin yung mga answers nyo on your worksheet. This is the pH as a function of concentration. So, let us just read the problem statement. Based on the recorded pH of 0.1 molar of your sodium hydroxide in the experiment, calculate for the pOH, the hydrogen ion concentration, and then show your solution. So, very important na una pa lang, pag binasa mo yung iyong problem statement, alam mo na kung acidic or basic ang iyong chemical solution. Kasi doon ka mag-base kung ang gagamitin mo na formula is ito ba or ito ba. Okay? So, una pa lang, dapat alam mo na para yung mga susunod mong steps, hindi ka na magkakamali. So, based on our problem statement, isa po siyang basic solution. Your sodium hydroxide solution. So, ang gagamitin natin na formula dyan is your pOH is equals to the negative log of your hydroxide ion. Tama po ba? Next, for the pOH is equals to the negative log of your 0.1. 0.1 po yung ilalagay natin dito na value kasi galing po siya dito. Okay? Yun po yung molar concentration of your hydroxide ion. And then, if i-input lang natin sa ating calculator, pOH is equals to the negative log of 0.1, ang magiging final answer natin dyan ay pOH is equals to 1. Okay, kindly check kung nag-arrive tayo sa same answer. Next naman po is kukunin na natin ang ating pinaka-hydrogen ion. So, ang gagamitin natin na formula is your pH plus pOH is equals to 14. Okay, 14 ito po ay constant. So, ito yung ating formula na gagamitin. So, pH plus pOH na 1, based lang dun sa sinolve natin kanina, is equals to 14. So, ang susunod natin gagawin dyan is ililipat natin si 1 sa kabila. Bakit po? Para makuha natin yung pH. Kailangan ma-retain yung pH, so, dapat nating ilipat si 1 sa kabila, and then, pag nilipat mo si 1 sa kabilang side of the equation, magbabago yung kanyang sign as a rule of math. So, magiging 14 minus 1 yan, and then, magka-come up tayo sa result na pH is equals to 13. Next naman po is we will get your pH pa din. Okay? pH is equals to the negative log of your hydrogen ion. So, gagamitin lang natin yung ating anti-log, okay, sa ating calculator. So, 13, yung pH 13, nakuha lang din natin yan dun sa sinolve natin kanina. Okay? pH na 13 is equals to the negative log of your hydrogen ion, and then 10, i-replace lang natin siya doon sa nakuha nating pH. So, we will come up with the result of 1 times 10 to the power of negative 13 is equals to your hydrogen ion. So, kung gagamitin natin yung anti-log sa ating calculator, magka-come up tayo sa ganitong result. Okay, kindly check kung same tayo ng answer. So, ito po siya, in a tabular presentation, ito yung ating ginamit na chemical solution. So, itong mga examples lang po iyan. So, pwede nyo siyang i-practice at home. Try nyo kung mag-a-arrive tayo sa same answer. Okay? Yung hydrochloric acid, and what if yung hydrochloric acid mag-add ng water, ng distilled water. So, ito lang po yung i-focus natin for this discussion. Kasi ito lang yung chemical solution na diniscuss natin sa ating laboratory demonstration. So, kung yung theoretical concentration, paano po siya naging 0.1, i-discuss natin yan sa ating mga susunod na slides. Okay? Next is your pH as function of concentration. Ito yung question number 2 nyo on your QFR, or on your worksheet rather. After the addition of distilled water in your sodium hydroxide solution, theoretically, what is the new concentration of your sodium hydroxide? Sorry, this is a typo error. Sodium hydroxide solution. And then you have to show your solution. So, ang gagawin lang natin dyan, ilalapat lang natin or ilalatag lang natin ang ating mga given. So, we can now proceed to our problem solution. Okay? So, ang ating given is the 1 ml of your 0.1 molar of your sodium hydroxide solution. And then, meron tayong 9 ml na distilled water. So, meron tayong 10 ml solution. Okay? Ang gagamitin nating formula is the C1V1 is equals to C2V2, the initial concentration times the volume. So, ang ating C1 is your 0.1 molar of your sodium hydroxide. Next naman, the volume is 1 ml. Okay po? And then, ang nawawala natin is the concentration of your distilled water. Okay? And then, the volume is 10 ml po nung ating solution. So, kung i-apply lang natin ang ating formula at isa-substitute lang natin sila, magkakama po tayo sa 0.01 molars. Okay? Kindly check kung nag-arrive tayo sa same answer. Okay? Ang formula na gagamitin, do not forget, is C1V1 is equals to C2V2. Ang concentration 1 natin is your 0.1 molar of your sodium hydroxide solution. The volume 1 is 1 ml. And then, ang nawawala is yung concentration, yung pangalawang concentration. And then, the next volume is your 10 ml. 10 ml po yung gagamitin natin, ha? And then, kung gagamitin lang natin ang ating rules of math, magkakama po tayo sa answer na 0.01 molar. And then, that would be our final answer. Okay, kindly check. Hence, we have our theoretical concentration of 0.01 molar of your 0.1 molar hydrochloric acid and then your 9 ml distilled water, same sila. And then kapag ka naman 0.1 molar sodium hydroxide solution and 9 ml distilled water, same lang din po. Okay? Next naman, for the question number 3, the new theoretical concentration of sodium hydroxide after the addition of distilled water, calculate for the pOH, hydrogen ion concentration, and you have to show your solution. Again, basic na naman po ang ating chemical solution. So, ang ating gagamitin na formula is the pOH is equals to the negative log of your hydroxide ion. Okay? And the next pOH is equals to the negative log of your 0.01 molar. Kasi ito na yung nakuha nating new theoretical concentration. So, yun na yung gagamitin nating 0.01. Ito po siya. Okay? And then, kung i-apply lang natin siya sa ating calculator, magkakamap tayo sa pOH is equals to 2. Okay? So, important na makuha nyo muna yung theoretical concentration of your sodium hydroxide before proceeding to this step or question number 3. Kasi magkakamali kayo sunod-sunod na kapag hindi nyo kinuha muna yung theoretical concentration natin. Next naman, you have to get your pH. Same pa din for our formula. pH plus pOH is equals to 14, which is your constant. And then, i-substitute lang natin. pH natin pa din ang nawawala. Okay? And then, 2 coming from the pOH that was solved earlier is equals to 14. And then, ililipat lang natin yung 2 sa kabila. Magiging pH is equals to 14 minus 2. Hence, we will have pH is equals to 12. Okay? Next naman, we have to get our hydrogen ion concentration. pH is equals to the negative log of your hydrogen ion. And then 12, ito pong 12 na pH natin, kinuha lang din natin dito. Okay? And then, using your antilog on your calculator, 10, okay, magiging to the power of your x daw. Okay? So, substitute lang natin si 12, 10, to the negative 12. Kapag ka-in-apply natin sa calculator, pakitry on your own, magkakaroon tayo ng sagot na 1 times 10 to the negative 12 of your molar of your hydrogen ion concentration. Okay, do not forget na pakigamay yung inyong calculator para alam natin kung paano mag-work si anti-log on your calculator. So, ito na po yung pinaka-answer natin on your number 3. Okay, pOH of 2, the pH of 12, and then the hydrogen ion concentration, which is your 1 times 10 to the power of negative 12 molar of your hydrogen ion concentration. Next, let us now proceed to your questions for research. Question number 1 would have to be, how does a buffer work? A buffer maintains a particular pH when added to the solution. It reacts to any added acid or base to control your pH. It either replaces a strong acid or base with the weak one. Example natin dito is yung addition of H3O2, H2PO4 is equals to the HPO4 buffer. Okay? Since hydronium ion is added, which is an acid, the one that will react in the buffer is the conjugate base. That's why the reaction would be this one. Okay? Ganun po nag-work ang ating buffer, katulad ng diniscuss natin sa ating laboratory proper. Okay? Yung buffer, nagme-maintain lang siya ng particular pH kapag inad mo siya sa isang solution. So, that's basically how your buffer works. Next is we have to give examples of buffers in biological systems and describe how these react to pH changes. So, one of the most common buffer in our biological system or in our body is the carbonic or bicarbonate buffer, which can be found in our blood. Again, the most common buffer is the carbonic or bicarbonate buffer, which can be found in our blood. The blood contains large amount of carbonic acid, which is a weak acid, and a bicarbonate, which is a base, to maintain the blood pH of 7.35 to 7.45. Bicarbonate neutralizes excess acids in the blood, while carbonic acid neutralizes excess bases. As a value then 7.8 or lower than 6.8, it can lead to death. So, magkaroon man ng onting imbalance sa ating pH of our blood, maaaring maka-encounter ng mga complications si patient. Okay? So, very important na ma-maintain lang natin yung pH ng ating blood to 7.35 up until 7.45. So, here are some of the examples of the pH buffers that can be found in biological systems as well. We have your phosphate buffer, your protein buffer, and then your hemoglobin buffer. Your phosphate buffer, it acts in a manner similar to the bicarbonate buffer but has much stronger reaction. The internal environment of a cell contains this buffer comprising hydrogen phosphate ion and dihydrogen phosphate ions. Next are your protein buffer. Proteins consist of amino acids held together by peptide bonds. The amino acid possess an amino group and carboxylic acid group. At physiological pH, the carboxyl acid exists at the carboxylate in ion with a negative charge, and the amino group exists as your NH3 ion. Lastly are your hemoglobin buffer. The respiratory pigment present in blood, hemoglobin, also has buffering action within your tissues. And then for our last question in your questions for research, why is acid always added to water and not the reverse? Okay, so ang simpler terms for that is that a large amount of heat is released when strong acid are mixed with water. Yung exothermic reaction natin, nagte-take place siya kapag inuna mo yung water to acid. Okay? And then adding more acid releases more heat. If you add water to the acid, you form an extremely concentrated solution of acid initially. So much heat is released that the solution may boil very violently, splashing concentrated acid out of the container. If you add acid to water, the solution that forms is very dilute and the small amount of heat released is not enough to vaporize and spatter it. So, it is always acid to water and not the reverse. Okay? So, ang palatandaan natin dyan is yung parang ating, para kang taga-UK, para kang British, acid to water. Okay? Acid to water, always acid to water, and never the reverse. So, that's basically our discussion for your post-lab discussion. Thank you and God bless.